Hey everyone, welcome to our video demoing the Cora Z7 FPGA Basic I/O project provided by Digilent. First, a little background on the Cora Z7 board. This board is designed for digital logic designers and embedded software developers who want to implement custom hardware solutions. The Cora Z7 is also great for students looking to learn more about FPGA development. It was actually the first FPGA that I developed on personally in college. In this video, we will be showcasing the basic I/O capabilities of the board. The Cora Z7 board is built around the Xilinx ZYNQ 7000 FPGA, which combines a dual-core ARM Cortex A9 processor with programmable logic. The board has a variety of peripherals including Ethernet, USB, 2 push buttons, and 2 RGB LEDs. And it is designed to be used with the Vivado design suite from Xilinx, which we will be using in this demo. For this demo, we will be using the GPIO pins on the board to control an LED and a push button. This is the expected result of the end of our demo. If we push a push button, it should turn off that LED. And if we select the other one, it would do the same. Now, let's go ahead and hop into programming our FPGA. For this demo, we will be programming the FPGA using the provided Verilog code from the Digilent and Vivado design suite from Xilinx. The steps in this video are not going to include the installation of Vivado and the import of the board files, which need to occur before this video. If you need steps to install everything required for this demo, please go to the link in the description below. Alright, so first things first, we gotta download the zip file from the Digilent website, which I'll provide in the description below. And then we scroll down to our FPGA, which is the 07S, and go to Release Zip Downloads. After that, we can now download the hardware zip file. Once that's downloaded, we can go ahead and extract that to a directory of our choosing. I have already created one for this demo, and so that's where I'm going to be saving it. And extract. Awesome. So now that that's extracted, we can now begin to make our Vivado project. So we can go ahead and open up Vivado. And now we can go ahead and create a project. I always just create a new project and import their files instead of using their created Vivado project just to minimize the issues we could run into. All right, so now we can change this to whatever we want. We can say Cora Z7 demo, and we're going to keep all the default selections, and this is where we add our sources from the zip file that they provided. So if we go to where we saved it, in my case, desktop, Cora Z7 demo, hardware, sources, imports, HDL, and we're going to want to import all three of these sources into our project. And if we just do the control and select each one, we can import all three at once. And we keep everything else the same, all the defaults. Now we upload our constraints. Our constraints files is going to be under sources as well. Constraints, imports, constraints, and we're going to import that one single constraint file. All right, now that we have our constraints file, we can go ahead and select our board. So if we just head over to boards, and for simplicity's sake, if I just type Cora, it gives us these different options. And there's two different options here. It doesn't really matter which one you choose. I'm choosing the one that I have already installed on my system. So we're going to go with that one, 07S, and click Finish. Now it's creating our project and bringing in all those files that we got from Digilent. Awesome. Now that our project is done initializing, we can go ahead and just browse through the different code that was imported on our setup. So here is our top Verilog code. It pretty much has the basics, has the input wires. That's our clock, our LEDs, red, green, blue, red, green, blue. This code is basically going to loop through red, green, and blue LEDs on this code is basically going to loop through red, green, and blue on each of its LEDs. So here we have our All right, great. Now that we have our project imported, we can go ahead and look at the different files that were given to us from Digilent. Here we have the top, which has all of our inputs and outputs and where the logic occurs. And in later videos, we'll take a deeper dive into what all of this means and how it's implemented and what changes we can make to the code itself. Now that we've looked through all the code, we can go ahead and begin to compile and program the FPGA with the Verilog code. First, we have to start with synthesis. Synthesis is an essential step in the FPGA design flow that converts HDL code into digital circuit implementation, which can be further optimized and implemented on the FPGA device. Once that's completed, the next step is implementation. Now, implementation is important because it's another critical step in the FPGA design flow that maps a design's logic level representation onto the physical resources of the target FPGA. Lastly, we need to generate a bit stream. So we can go ahead and click here, generate bit stream, press OK. And we need this step because a bit stream is basically a binary file that contains all of the configuration data required to program an FPGA device and configure its resources. Awesome. Now that we're done with this, we can go ahead and actually program our device. So if we go to Open Hardware Manager, that will give us the options to open our target. And I usually always just press Auto Connect so that it can find my FPGA for me. And as you can see, it found our FPGA, and now all we have to do is program it. So we program, and we're going to use that bitstream file that we just created and program it. Now we can look at the FPGA and see what's going on. So as you can see, we have our red, green, and blue. And if we press our push buttons, it turns off that LED. And if we press this one, it turns off this LED. And if we push them both, they both turn off. All right, so that's going to be it for this video. We were able to program the Cora Z7 FPGA, and in the next videos, we'll actually jump through the code and understand everything that Movado is doing in order to implement this design on the FPGA. So brief summary, the Cora Z7 FPGA is a powerful tool for digital logic designers and embedded system developers who want to implement their custom hardware solutions onto an FPGA. With its variety of peripherals and powerful programmable logic, it can be used for a wide range of applications. Thank you for watching our demo of the basic I/O capabilities of the Cora Z7 FPGA board, and stay tuned for more videos where I will be diving into the Verilog code piece by piece so that we can gain a better understanding of how the code is implemented. Thanks, and see you again.